Every good VR game starts with interactables. In VR, rather than interacting with things on our keyboard or through pressing buttons and moving our mouse around, we interact with things physically by reaching out and grabbing them. Today, we're going to go over how you can create interactables in a scene and make them useful to your game and effective for your gameplay. To start, I have our player that we created in the last game with our continuous move, our turn provider, locomotion system. So if we go down to our left and right controllers, we have both something called our XR controller, and we also have something called an XR ray interactor, and an XR line visual and the sorting group, as well as the line renderer. Now, what this does is it creates a raycast from your hand to an object, and when it interacts with that object, the line renderer turns on, and you can then see the raycast that is being casted. Now, in VR, this allows us to interact with things from a distance. This would allow us to reach out and grab things on, say, a UI, or even like physical objects in the world, which becomes really helpful when you're playing a game that, let's say you drop your stuff on the floor and you don't want to have to bend over and pick things up. It's easier to be able to force grab objects. And maybe you want to manipulate them in space, depending on what your game is. It might not be a first-person game. It might be something like a city builder, and you might want to be able to move objects for the raycast. Nevertheless, ray interactors and XR grab interactables are incredibly helpful to your gameplay. So we're going to leave that actually on our right controller. Now, what I'm going to add for our left controller, I think it'll make you, yeah, there we go. You have to delete them in order or it will bother you about our components relying on other components. Now, what we're going to use for this is called an XR direct interactor. This allows us to directly reach out our hands and grab an interactable. Here you can see that there's an attached transform you could mess with, which allows you to position objects to somewhere on your hand. But I find it easier to use those attached transforms on the actual objects themselves. So this is all we need to add. If we wanted to filter our interactions or have audio events or haptic events that appear when we grab objects or when we interact with things, this is where you would be able to do it. This is the easiest way of doing it, in my opinion. It's just straight from the inspector here. However, you could do it from code as well. So in our scene here, you can see these are our hands. And on our hands is oh, never mind. What we do need is a collider. Now this collider allows us to detect collisions between our hands and other objects. And this is only required for a direct interactor. It would not be required for an XR ray interactor. So we're going to be able to change the radius here. We're probably going to want it to be around 0.1. Or let me check what I have. Yeah, so these are 0.1, and they also have a sphere collider, which I need to remove. Just realized. But these are essentially just meshes that look like our hands. Because if I wanted to go over the hands, I'd have to go over what an animator does. So on our left controller, we've added a sphere collider, and the important thing is that we want it to be a trigger. Now, what this means is that when the collider passes into another object, it is not stopped by physics. It is simply a field that detects when another object passes into it. So, if our circle here collided with another circle, it would detect, but it would not stop the circles from passing through one another. Now, what we're going to do here is change it to something like 0.05, and see if we can get the collider perfect there around our circle. So that's preferable to me, in my opinion. Now, let's say we want to interact with these two. I've made this little floating table here, and we've got this blue ball and a red cube. And these are simple. One has a box collider and a mesh renderer that renders a cube. and the other is just a sphere with a blue material and a sphere collider. Now, what we're going to want to do to these is we're going to add something called an XR grab interactable. Now, as you can see, this gave it a rigid body. This will not work without physics to some extent. So you'll need a rigid body on your objects. Now, okay. So on our objects here, we have a couple of settings we can go and mess around with. So if we want to set specific colliders for our objects, of which the places we can grab the item, let's say we only wanted to be able to grab the cube from the corner here. So we created we'll create what am I creating? Collider box here. If I want to just create another collider, box collider, and I moved it to the, hold on, and I moved it up, or in here, we're going to grab it from this bottom corner here. Essentially now, I could place this collider specifically into the collisions detected here, and it would only allow me to grab it from that position. Now, under here, we can change things like the select mode from single to multiple and the focus mode as well. The select mode essentially allows us to determine how many hands we're allowed to grab this object with. Multiple is usually just 2 because you don't really have more than 2 hands. Now, movement type is very important, and I'll go over this when we have both of them working and video of and proper demonstration. Instantaneous essentially refers to the fact that it is not affected by physics. The object will forever stay in the same spot on your hand and will instantly track every time. Kinematic means it relies on physics, and so does velocity tracking. Both of these allow the object to be bothered by physics and colliders. So if we were to drag our hand through the table here, they would create collisions, and the object would not instantly track to our hand. We can do things like forcing gravity on detach, which would affect the rigid body, but if we already have gravity set, it's not going to affect the thing at all. But if we didn't have gravity, and then when we grabbed it and let go of it, it would automatically turn gravity back on, which I'm actually going to keep that on because I like it when my objects don't fall through the table or onto the table. Dynamic attach allows us to grab the object from any position on the collider. I'll show you that in a few minutes when I have both of these set up. However, if it were a more complex object, like I'll get to later, we can create attach transforms for both the first and the second hand. And those become incredibly useful for many games when you want things to look very specific and you don't want players to be able to just grab objects randomly. Interactable events are very important. These are how we allow scripts to run and functions to run when things are activated or hovered over or selected within the game. These are incredibly important, and we will get to these later in a scripting episode. But there's some very simple and very important things you can do using interactable events. And there's also this throw on detach, which I didn't get to, but it allows you to better emulate physics when you're throwing an object or letting go of the object. So I'm going to jump right into this, and we're going to do some recordings of what goes on in game with these settings defaulted. Actually, before that, I'm going to set the cube to instantaneous, and I'm going to set the sphere here to velocity tracking, and I'm going to show the differences between those two. So let's jump right into that. All right. Now, as you can see, I'm currently in game, and on my left hand here, nope, this is my right hand. On my right hand here, I have a ray interactor, which, as you can see, turns white when it's hovered over or placed over an interactable object. My other hand does not. It has simply the direct interactor. Now, if I move closer to the table, I can grab the ball here, and as you can see, it directly force grabs into my hand. Using the joysticks, I can actually push it away from my hands and spin it around. You can't really tell that it's spinning because it's just a sphere. However, I can hold the object in my hands, and as you can see, there's a slight bit of delay because this object is velocity tracking. Thus, it is using physics to determine where it should be based on my hand and the speed of my hand. Now, if I push my hand into the table, as you can see, I'm pushing my hand downward. The object is stuck on the collider of the table. If I kind of pull my hand out, you can see that my hand is currently in the table, and yet the ball is still at the top. And it'll roll over the side if I attempt to move it into the table. Now, that's velocity tracking. Incredibly useful for games where you don't want to break the immersion for your players. I can also toss the ball, and it's a little bit funky because we didn't really set the throw on detach. Now, if I reach out here and not grab my microphone, I can grab the cube. The cube, as you can see, the joystick does nothing. However, I can now, it is now instantly tracked to my hand. Thus, I am able to, there's no delay whatsoever, and it is always where my hand should be. I can also pass this cube through the table, and it pretends as though the collider does not exist. Does not think that there needs to be a collision here. It just doesn't understand. So it is always instantly tracked in my hand. These are the main two interactors we use during gameplay for physics-based games or for just entertaining interactables. So now we're going to get into some more complicated interactables with a sword. All right, so now we're back in Unity, and we can start working on something a little bit more complicated. Now, as you can see in my prefabs folder here, I have a broadsword. I think it's scaled a little bit small, so we're going to do 1.5. But essentially, let's say I wanted to pick up this broadsword in VR. Now, rather than just giving the entire object here an attached transform, I actually have this object split into separate bodies. This came right out of Fusion 360. This is some old model I used to work with back in the day. But let's say I wanted a collider on the hilt that would allow me to pick up the sword from the actual hilt location. So what we're going to do is we're going to make the radius... Actually, the radius is fine. We're going to make the... Oh, it's the wrong axis. Let's try this. Essentially, we want to scale this transform down. It's probably fine if it's a little wide, but in any sense, you'd be able to modify it here in these controls. Now, I'm going to make it a trigger so we can interact with it without actually pushing it around. And we're going to give the rest of the body... Actually, no, we're not. This broadsword overall component needs an XR grab interactable. Now, it applies a rigid body, which we've already seen, and we're going to make it so it doesn't use gravity. And then here, we're gonna keep the focus mode as single, but what we're going to want to do is create an attached transform down here. This will allow us to grab the sword at a very specific angle or position. So I'm going to go here and create an empty game object, and we're going to call it attached. Now, as you can see, I can position this whichever way I want. The blue arrow typically refers to the forward axis. So essentially, when we grab the sword, we're probably going to want the forward facing this way. So we're going to move it a couple degrees that way. And as you can see, it's pretty much in the center of the sword, but we might want to drag it a little bit downward. Now, when we go to our broadsword, we're going to go here and we're going to drag attach transform into the attach transform. And we're not going to dynamically attach this time. Oh, I didn't even show you dynamic attachment. That's fine. And we're going to keep it instantaneous because I like it when my swords, when I just can, I feel like I'm stronger than anyone. So I'm going to jump right in and show you exactly how the attach transform works. And then we're going to go over how I could dynamically attach to this sword using my hand. So real quickly, before I move on, I did something kind of silly. Now, what's easier for your games is to create your colliders directly on the overarching object. And this allows you to better manipulate where your colliders are. Let me grab the edit collider tool. Alright, now I have now jumped into Unity, and our sword's being kind of funky. But when I grab it, it now automatically sits to the transform that I set it to. And I did finick with the transform a little bit because it was not working. I rotated it wrong. You should do 90 degrees on the Y and the Z, and then it looks like this, rather than like this or like this, like it was before. I can grab it with the direct interactor, as well as the ray interactor. And when I drop it, it doesn't have a automatic gravity on release. As you can see, the collider doesn't really collide with anything because there is no collider on the actual blade. There was just the collider on the hand here. And it is also instantaneous, which means it's not velocity tracking and shouldn't track collisions anyway. So now what we're going to show you is dynamic attach, where I would be able to grab this wherever I so please. Okay, so now I've jumped back into Unity. And what I'm going to do now is show you how to create a dynamic attach on any kind of object in your game. Now, what we're going to want to do for this is remove, or well, not remove, we're going to disable the capsule collider for now. And on all 4 of these bodies, we're going to go ahead and grab a mesh collider. Now, I don't typically use mesh colliders because they're usually not perfect. However, this will satisfy for this event since we don't really have an object that can be easily set up with colliders. And I don't have time for that right now. So what we're going to do now is we're going to remove the attach transform. And we're going to set this to dynamic attach. Now, this will match the position, the rotation of our hands when we grab the object. So we're going to go test that out now, and I'm going to show you what that looks like. All right, now, both of my hands are direct interactors, and thus I can grab the sword from any position I might want, including the blade and any other place where we had a collider. It also means I can position my hands as best as I want. Like, let's say I wanted to choke up the hilt of the blade, or grab it from a little bit farther back and have a little bit more reach. So this works in some cases. A lot of games don't use this because it does allow the player a little bit too much control. Or like if I wanted to just grab the sword blade and hit people from the other side, that wouldn't make too much sense in some games. However, for the most part, this is a pretty cool interaction tool, and it definitely has its use cases. So what I've done now is I've jumped into the demo scene. And in the demo scene, they show us these poke interaction examples, and they also show us some other grab interactables, and they show us what the instantaneous, the velocity tracked, and the kinetic movement looks like. So this is a great place to go if you're just learning and you want to just fool around and test around with all the different interaction types. This also shows how to interact with windows on a UI, which, if I go over really quickly, is simply just having a tracked graphics device graphic raycaster, which checks for the raycasted by the interaction and allows you to interact with things like buttons and drop downs and all such like that. So I think that concludes our video on interactables and interactions between objects in Unity. And I hope you learned something, and go Gators.